All right, so Unit 7 begins with talking about growth and decay, and these are our exponential functions. So we want to look at the base. When it asks whether it's growth or decay, you're looking at the base, the one that's attached to x, and as long as it's bigger than 1, we're going to say growth. So 3 is bigger than 1. Even 5/3, if you convert that to a decimal, that's bigger than 1. And again, it's the one that's directly attached to x, so that one is also growth. If our base is less than 1, so something like 1/2 is the same as 0.5, that's less than 1. 0.3 is less than 1. And this one we're going to actually say neither. It doesn't represent growth or decay because it equals 1. All right, if we want to write something in logarithmic form, that means that we want a log in our answer. And these are called my base. If you remember, on a log, the base is the little number. So we move that into, we read this as log base 3 or log base 8. And these are the ones where I kind of compared them to a cheerleader base. If you're thinking about cheerleading, the person on the base is the person on the bottom. And then these, the base holds up the flyer. And so I always say the flyer gets tossed into the air, and then they are up in the air all alone. So we're going to put that flyer alone. And now the 60 and the 80, those are called the argument. So we would read this as log base 3 of 80 equals x, log base 8 of 60 equals x. Now don't forget, again, when they say check for extraneous solutions, you want to sub it back in. In our first one where they say to solve, the nice thing is that I can make 49 into 7 squared so that the bases are going to match. Now when I make this 7 squared and you bring down your binomial, put it in parentheses. And I'm just going to bring down that right side. So once the bases are the same, you can actually cross them off. And now we just have our equation 6x plus 10 equals x plus 9. And it's just a basic linear equation that we want to solve. So I'm going to move the x, making this 5x plus 10. I'm going to subtract 10. Move over here. And I'm going to divide by 5. So negative 1/5. Remember, we don't want to call this our solution until we sub it back in. And in this case, it should work. And you guys can do the checking part on your calculator. Here I'm going to subtract 6. Now this one's a little bit different. The last one we were able to turn 49 into 7 to make the bases the same. But 14 can't become 100, so actually what we're going to do is use our log. If I take the log of 14, what it does is it causes that exponent to fall to the front, if you remember from our expanding rule. But whatever you do to the left, you have to do to the right. So I'm going to take the log of 100. Remember, your goal is to get x alone. So to get x alone, I need to remove the 5. And I'm also going to remove the log 14. So I'm dividing by 5 log 14. And your calculator is going to do most of the work for you in this unit. Alright, so we're going to divide by log 100 divided by. And then I'm going to group the 5 log 14. So I'll have 2 ending parentheses to close off with the 5 to show that the 5 and the log 14 are both in the bottom. So I'm going to get 0.35.